Good evening, dear faculty. Thank you for joining the session and welcome to the day four, sorry, day five of the FTP session on VLSI systems, VLSI driven FPGA systems. We are very happy to have you all here. Thank you for joining. So we will wait for two more couple of minutes. Meanwhile, our beloved faculty will join. So I request everyone to those who I request you to inform your colleagues, those who have registered for this program but not yet joined. Please ask them to join as soon as possible. We'll start the session straight away. Yeah, dear faculty, I hope you have received your mails on time regarding recording sessions and drive links of the learning resources. Am I correct? Please respond anyone of the session, anyone from the session. Have you are you receiving your mails regarding recording sessions and resources? If yes, please give some thumbs up. Yes.
Yes,
Thank you.
we are
Thank you.
listening.
Thank you so much. Thank you so much. Yeah. So straight away we'll start the session.
Yes, sir.
Yeah. Please. Thank you. Thank you. Thank you so much, dear faculty. Yeah. So we'll straight away start the session. Just a moment. Yeah, Tejas, I think we'll start the session straight away. Tejas, are you there? Am I audible to you?
So good evening to all. Yeah, am I audible to you? Hello. Am I audible to you? Is my voice is audible? Yep. So yesterday we are discussing about the combination circuit. Okay, the full adder is the combination circuit. You people are know about it very well. Okay, but now we are implementing the sequential circuit. So now we are implementing the sequential circuits. So you people please observe that what is the difference between the FPGA dumping between the combinational sequential. So what we need in the sequential, okay, only one extra element we can add it in the sequential circuit, that is clock. Okay, suppose we will take one example of JK flip-flop. I have a code also. I'm already written the code of JK flip-flop. Okay, so I will open it and I will dump it in FPGA board. So you people need, please observe that, all of you. I will open the cam, I will on my cam, and you people need to observe that. So what is the difference happening if we dump the sequential circuit? That is the static, it gives the output like static, but the sequential, I mean the combination is like a static, but in sequential we need to know about it very well. It's a memory related. Yeah. So the sequential is memory related. Okay. Now I will open the JK flip-flop. The example is well suitable. The JK flip-flop is suitable for this situation. Yeah, I will open one thing. I will open one JK flip-flop, whatever it may be. Yeah, just a minute. Yeah, is my screen is visible to you? Okay. So the same process, you please follow the same process for JK flip-flop or whatever it may, full adder or half full adder or JK flip-flop. You have to follow the same process of simulation or pin connection, whatever it may be. Okay. So I am already connected the pins also. I think you people are observe this one. W5, W6. Just a minute, I will check the pins. Which board is related to this one? Click on background. And of course, okay, test bench is there. Yeah. Okay, this is the base history. Previously, I am done this code in base history, so that's why we need to change this board. Okay, we need to change the board. Of course, XC7A 35T FPG 256 1. See, this is the H Arctic 7. Okay, it is available for me only. So click on OK. So I'm deleted my previous XDC file. Just a minute, it will be loading. Yeah. So now this is my pin file. This is my XDC file is related to base history board. So now I am remove this project. So we need to connect the new one. Yeah. So now coming to the 4 input output port. So you have to follow the same process. Okay. Just you can open your H Arctic 7. Just you can open your Edge Arctic 7 board. This is my Edge Arctic 7. So you people are observe this one. So now I'm using I'm using LEDs and switches. Okay. So J, now I'm connecting the switch M6. Okay, M6. And N6 is for this second switch. And I will connect the T9 output for QN. Okay, T9 output for QN. So now please see this one very carefully. Sorry. So we need to know what is the clock pin. What is the clock package pin? See, if you want the clock package pin, you can directly know it. This is the pin N11. Already we are connected that. All of you. So these are my package pins. Don't worry, I will explain the code, what I'm written in JK flip-flop. Okay, everything will be done. Now I'm giving the normal name of JK. That's it. Yeah. So I will generate the bit stream. Okay. Yeah. So now the bit stream was running here. It will take 1 or 2 minutes time. So coming to the JK flip-flops, coming to the JK flip-flop Verilog code. So this is my JK flip-flop Verilog code. What I'm writing here, I'm using the case condition. So you people are know about it very well. So 0 0 0 QN same, no change here. For 0 1 0 output, 1 0 1. And what is this meaning of 1 1? Can anyone tell me? What is the this meaning of 1 1? What happening in the situation of 1 1 condition for JK flip flop? I mean, manually, no problem.
Toggling, sir.
Toggling. So toggling in the sense, how can we find it? Find it in hardware, the toggling condition. How can we find it in hardware? That means it will show the LED blinking. Am I correct? Toggling means we know it very well. It will give the continuous output of 0, 1, 0, 1. I mean 0, 1, 0, 1, like this. So there is no constant output for this. So now we will see this, how it will show it. So we need to wait for the up to bitstream, write bitstream file. Okay. Yeah. So this is the JK flip-flop code and this is the test bench code. Okay. I think we can check the simulation also. That is also not, there is also no problem. We need to check the simulation directly. It will give the output. 1 minute. I will run the simulation. I will show the simulation. Oh God, it will also take time. Yeah. So I think you people are observing here for 1 1 condition 0 1 0 1 0 1 0 1. So still it is changing. So you people, I mean for 1 0 1 for 0 1, of course 0 for 0 0 we can give we are already given here the initial value, the qn 0. So that's why for 0 0 is 0 qn value. Okay. So now I will take my FPGA board. So yeah. So again, I mean same process. You can connect your. I will connect my board to my laptop. Yeah, I'm connected my FPGA board to my laptop. So I think you can click on the open target, auto connect. You can check this one. So now it is given program device. So you can click on the program device, program. So I will on my cam, just a minute. Yeah. So for just a minute, these two are will become high. Just a minute, I will redump it. Come open target, program device, program. Yeah. So now you can observe this one. So I am redumping. So for 0 0, this is 0. For 0 1, this one is 0. Okay. Sir, why it is previous program will be still give 1? Because that is the previous output. So now we will take 1 0. Of course 1. So 1 1, I want the toggle condition. You people know about it very well. See. Okay, and see, I will on the two switches. But there is no toggle condition. Why? What's the reason? Can anyone can tell me? Is there any reason behind on this?
Frequency, sir.
Yeah, frequency. See, the board internal clock is 50 megahertz frequency. If you run with that speed, 50 megahertz in the sense 20 nanoseconds. Okay, the 20 nanosecond speed, we could not observe that. You know, with the 20 nanosecond speed of LED blinking, definitely no one can observe that. Okay, so that's the major problem behind the extension topic of frequency division. The solution is frequency division. We need to use the frequency division. So what we have to do in this situation? How can we change the program? Okay, I will explain it. Okay. Yeah. So is my screen is visible to you? Hello? Hello? Can you please on your mic and please tell me, is my screen is visible to you? Yeah. Okay.
Yes, sir.
Yeah. So our problem is our internal clock is 50 megahertz. Okay. But I don't want this. That means 20 nanoseconds in timing. 20 nanoseconds. But I don't want this much of frequency. I don't want this much of frequency. So what we have to do? I want within speed of how much speed we want. I mean, human can easily observe that 1 second speed. 1 second speed is enough for us. See, the LED blinking within speed of 1 second, definitely. I think all of you, I think everyone can observe that. Okay. So what we have to do in this situation? Just a minute. So 50 megahertz in sense 20 nanoseconds. So I want to increase my time into 1 second. I want to increase my time. I want to increase my time. So what we have to do? We need to decrease our frequency. How much? So f is equal to 1 by t, 1 by 1 second, 1 H. So you need to convert. You need to do the division. You need to do the division to 50 megahertz to 1 H. So this is called frequency. So now we have to do the frequency division. Okay. We need to convert the 50 megahertz to 1 H clock. So for the 1 H clock, we have to use it for JK flip-flop. Then we can observe the toggle condition easily. That's it. Okay. We're using this 1 H clock for JK flip-flop. So for JK flip-flop toggle condition, we can easily observe that. Anyone have any doubt on this? Hello. Yeah, Severa sir, please. If you have any doubt, please ask me. Yeah. Yeah. Thank you. So this is the concept. So I will briefly explain this one. So what happening here? Just a minute, guys. This one. There is a technical glitch. Yeah, I think my screen is visible to you. So how can we convert it? How can we convert it? How can we do the frequency division? How can we do the frequency division? How? See, there is a one formula is there for this. The output frequency is equal to input frequency by number of mod counts. So this is the formula. So I think, yeah, I will explain. See, so what is my input frequency of my FPGA board? What is my input frequency? 50 megahertz. This is my input frequency of my FPGA board. You people know it very well. So I want how much output? 1 Hz. How much output I want? 1 Hz. So you need to easily replace with values. So 1 Hz, just a minute. 1 Hz is equal to this 100 mega, 50 megahertz. So now we have to calculate the how much of number of mod counts for this. So number of mod counts is equal to 50 megahertz by 1 Hz. So it is cancelled. That means 50 into 10 power of 6 counts. 50 into 10 power of 6 counts. But there is one problem. I mean, it's not a problem, just for clarification. So I want the output, say I want the toggle condition in only positive edge. You people are not, I don't want the complete cycle. See, this counts is for complete cycle of clock. See, for one clock pulse, this count 50 into 10 power of 6 for one clock cycle. But I want the output only either positive or negative. See, I want the output either positive or negative. So that's why what we are writing in the code. So we are writing the Verilog code. See, positive clock or negative clock. So I don't want the output. I don't want my output on clock pulse. Okay. So now I want only 1 edge. So I have to do division by 2. Okay. So now my final count is 25 into 10 power of 6 mod counts. So this is the solution for that. Okay. This is the solution for that. Sir, how can, okay, sir, you are use one formula. Okay, you have done the calculation. Okay, our answer is 25 into 10 power of 6. Okay, what next? What next? How can we use this 25 into 10 power of 6 counts? Now coming to this one, all of you. I will explain how it is acts. So this is the clock 50 megahertz. This is my clock 1 Hz. See, all of you. This is my J, K, Q, M. Okay. Yeah. So this is my 50 megahertz clock pulse. See this one. That means 20 nanoseconds. 20 nanoseconds. The time is 20 nanoseconds. This is my 50 megahertz clock pulse. So this meaning of 25 into 10 power of 6 count means it will start the counting of clock pulses 0, 1, 2, 3, 4. So some of it is reaches the sum of time. Okay, I could not write the total counts up to 25 into 10 power of 6. So sum of time it will reach the 25 into 10 power of 6. Sum of time it will reach the 25 into 10 power of 6. See this one. So what happened? See the clock edge, it is in low value, it in 0. It will change the, it will convert into the 0 to 1. Again, it is start the counting from 0. Again, it start the counting from 0. See this one. Again, it start the counting from 0. So again, okay, 0, 1, 2, 3, 3. So sum of, again, it is reaches sum of time, it is reaches the 25 into 10 power 6. So now the clock 1 H is again it is changes 1 to 0 value. See this one. So now again it is started from 0. Again it is reaches 25 into 10 power 6. Again it is changed that. It is converted 0 to 1. See, this is the clock 50 megahertz clock pulse. This is the clock 1 edge clock pulse. This is the 1 second clock pulse. This is the 20 nanoseconds clock pulse. More frequency, less time. Less frequency, more time. Okay. So now you can give the J1, K1 values. So the JK flip-flop using this clock only. So now it will detailedly can give the 1 second, 1 second toggle condition. Okay. So this is the theory. Sir, but okay, theory is okay, but how can we write the code? Okay, so theory is okay, okay. It is completed the 25 into 10 power 6 counts. Now the clock 1 edge will be changing from 0 to 1, 1 to 0, 0 to 1. It will be happening. Okay, the JK flip-flop will be follow that. The JK flip-flop is using this 1 edge clock. Okay, but how can we write it in code? I will explain this one. So this is the code is very important. How can I write the code? So please, all of you, please observe this one. I will write the JK flip-flop code. No need to worry about it. See, module JK flip-flop. So of course, J, K, clock, and QN. So same to same previous code. Same to same previous code. I did not change anything, but okay, we can declare input J comma K and output register QN. Up to here, everything will be same. But now I will take register clock 1 edge variable. See, we need, I did not use this clock for my JK flip-flop. If you want the toggle condition on FPGA on real-time hardware, so don't use this 50 megahertz. Okay, this is the inbuilt, this is a defaultly taken 50 megahertz clock. Yeah, and I'm taking the 31:0 count. Sir, this one is okay. Out for output. Okay, we need to use, this is the output clock. But what is this one? Okay, these are JK and QN are related to JK variables. These are JK elements, I mean JK flip-flop elements. So what is this 31:0 count? Why we are writing here? See, we need to count the 25 into 10 power 6 counts. So that's why I'm taking this to count that clock pulses. To count that 25 into 10 power 6 clock pulses. So for counting that much of clock pulses, so that's why I'm taking this one. Okay, all of you. So this is the input output declaration for JK flip-flop for updated code. Okay, including the frequency division. So all of you please see this one. All of you please see this one very carefully. Now you need to write the initial values. That is the very, very important. Initial begin. You have to use the non-blocking for the sequential circuit. Clock 1 edge and of course and count. That's it. So I'm writing here. I will write the code here. I'm continuing from here. See, I'm writing here. Next, what is my next step? Definitely, okay. My next step is to write the always at the rate passage clock. Passage clock begin. Of course, case of, I mean, J comma K. So 2-bit 0, 0. I mean, I'm using the case condition. 2-bit 0, 0, QN less than or equal to QN. Of course, next one is 0, 1 values. 2-bit 1, 1. QN less than or equal to not QN. So this one is my toggle condition. See, this one is my toggle condition. See, from here, there is a main point. Why it is running with 20 nanosecond speed? Why this program is running with 20 nanosecond speed? I am using the 50 megahertz clock. So just remove this clock. Okay, just remove the clock. Don't change any kind of program. why the toggle condition within with running, I mean with speed of running 20 nanoseconds, because we are using the 50 megahertz clock. Okay, this is the defaultly taken the 50 megahertz. So that's why this, not only this toggle, this overall program will be running with this always loop with running with 50 megahertz speed. Okay, so now I'm removing this clock. I did not use this clock. Now I'm writing the frequency division. I'm doing the frequency division. Always at the rate passage clock C. Passage clock begin. So if of count is equal to, so what is my maximum count? So what is my count? I mean, what is my maximum count to count for the clock pulse? 25 into 10 power of 6. See, yeah, anyone have any doubt? Yeah, just a minute. So 25 into 10 power of 6. So count is equal to 25 into, so don't write like into 10 power of 6. So we have to write, you have to take the value. Okay, 25 into 10 power of 6. That is the meaning. So if it is reaches the 25 into 10 power 6, so what happened? All of you please see this one. If the count reaches the 25 into 10 power 6 in this waveforms, what did you observe? Is there any changes? Again, we need to start the count from 0. Change number 1. We need to start count from 0. This is the first one. And of course, the clock 1H from changing to 0 to 1. And again, coming to next situation, this situation. Okay, this situation is also like that. So, of course, if it is reaches, then 25 into 10 power 6, 0. But now, this one will become 0. That means this is the second condition. See, first one, second one. Now, please see this one, how I am writing the code. If the count reaches the 25 into 10 power 6, my count value will become 0. And my clock 1H, what about my 1H clock? See, if my clock 1H value is 0, if it is reaches the 25 into 10 power 6, then my clock 1H value will become 0 to 1. Otherwise, 1 to 0. If it is reaches the count at 25 into 10 power 6, the count value will become 0. And again, the clock 1H is also changing. I mean, opposite, 0 to 1, 1 to 0. Okay. Else condition is also there. Else, of course, you people are know about it very well. This is the counter code. If it is not reaches the 25 to 10 power 6, what working of the counter? Incrementation. See, I'm not reaching the 25 to 10 power 6 here. So 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5. Only incrementation. That's it. Only incrementation. So simply you can write count less than or equal to count plus 1. That's it. Okay, sir, everything will be fine. But what is the relation between these two always blocks? See, here I'm using the 50 megahertz clock. Here I'm using the 50 megahertz clock. All of it, please. Yeah. So here I'm using the 50 megahertz clock. I'm using the counter clock pulses. So I am getting this 1 second clock. This is the 1 second clock 1H. So now I'm using this 1H clock here. Now I'm using the clock 1H here in this JK flip-flop code. So now my toggle condition will be not running in 20 with speed of 20 nanoseconds. Now it is running with 1 second. Okay, so this is the total information related to the frequency division. This is, I mean, you no need to change the frequency division code. If you use the same code for counters, any kind of like this ring counter, twisted ring counter, or mod 10 counter or synchronous, asynchronous. Just change the subject code. This code is everything will be same. If your clock is 50 megahertz, then your code is same. Okay, no need to change anything. You need to change this input output variables according to your subject code. That's it. Okay, for sequential circuits, what I'm saying. So now, okay, I will show it in real time. I mean, I will write the code. Okay, now I am writing the code using the clock 1H register count. Of course, 31:0 count. Yeah. So initial, begin. So Qn, yeah, already Qn I'm taking 0, but no problem. Qn less than or equal to 0. Clock 1H less than or equal to 0. Count less than or equal to 0. Okay. So now we need to write the frequency division code, all of you. So you no need to change anything on the subject code, just we need to change the clock. Okay, because of it, this toggling is running with clock speed. So now I'm writing frequency division code, always @posage clock. Begin. So if of count is equal to 25 into 10 power 6. Yeah. So the begin, of course, count less than or equal to 0. The clock 1H less than or equal to not clock 1H. Yeah. So and else, just a minute. Else count is equal to count plus 1. Some members are doing use the blocking for this sequential circuits. Okay, don't use the, you have to use the non-blocking for sequential circuits. Okay, this is according to the design guidelines. All of you, according to design guidelines, now I'm using the clock 1H clock. Okay, now we are using the clock 1H clock. Yeah. Don't worry, I will check it on I will check it and I will open the, I will show it in FPGA board. Okay, so same code. So JK is, I'm just doing the, I will checking. Okay, everything will be perfect. So we need to run it. Doing do and run implementation. Yeah, there is no need to change on the pins. See, there is no need to change any kind of package pins. Okay, the pins will be same. Yeah, it will take off a little bit of time. We need to wait for that. Okay. So if you have anyone have any doubts, so please ask me. Okay, on this frequency division, anyone have any doubts? So please ask me. So if your board frequency is 100 megahertz, some board, so for basis 3 Nexus A7 is 100 megahertz clock. For Spartan 3 is also 50 megahertz. Okay, you can use the same code for Spartan 3, for Nexus A7 or Basis 3, that is 100 megahertz. Internal clock is 100 megahertz for them. Yeah. So still it is an running. So if you have anyone have any doubts, definitely you can ask it. I don't have any problem. Anyone have any doubt on this frequency division concept? See, this is the very important concept to interfacing the LCD. I mean, for any kind of hardware peripheral, if if you want to use any kind of hardware peripheral, definitely you need to learn about this frequency division. Okay. Jetboard is yeah. You need to check that. I mean, Jetboard 7000. Yes. Just a minute. Yeah, the Jetboard is manufactured by Xilinx company. They have 100 megahertz. Yeah, it's a 100 megahertz board. So you need to. It's a 100 megahertz.
Sir,
Yeah, please.
sir, actually,
So again, we need
Z-board,
to
it
run the.
contains both PL and PS, no, sir? Is there different clocks for PL and PS or same clock for PL and PS?
Yeah, some FPGA boards have different clock pins. I mean, 32.33 megahertz and 50 megahertz, 100 megahertz. You can use it as for the pins for package pins.
Okay.
See, I am connected the 50 megahertz clock pin. I will show my package pins. Only there is a one clock in my on my FPGA board, so that is 100 megahertz. That's why I am connected. This is not my code. We need to update this one. Yeah, just a minute. So for few FPGA boards have different clocks. Of course, 100 megahertz, 33.3 megahertz. But you need to use the main clock. You need to use the global clock. That's it. Okay,
Okay.
that's a very good thing. Yeah. Yeah. So there is only one clock in on my FPGA board. This is the global clock of my FPGA board N11. So that's why I'm connecting this one. Okay. So the bitstream was running here. Just a minute. So now I'm connected my FPGA board. I will show my output. Yeah. So same procedure. Click on the open hardware manager. So open, I mean, of course, open target, auto connect. So now it will be checking whether the board is connected or not, checking the status. So now you can click on the program device, program. That's it. Just a minute, I will redump it. Yeah. What happened to this one? Just a minute, guys. Why it is not updated? Just a minute. There is a previous HTC file is there. We need to remove it. It will print. I mean, it will dump the previous bit file. Just a minute. Sources. Yeah. So now we need to done the again run implementation. Sorry guys. I mean the file is not reloaded, so that's why I'm again reloading this file. Yeah, everything will be perfect. Yeah. Yeah. Okay. mm, we need to connect the pins again. Clock and 11. This is M6. T9. Can cancel it and control plus yes. XDC. I mean sorry. Or you can give the JK. Yeah. Okay. Okay. The previous for the last time the previous file was dumping. Continue. So anyone have any doubts? You can ask me. I don't have any problem. I mean, so this is the total information about the frequency division. Don't worry, I will send this notes to you, and I will send the code also. I mean, because of why any related hardware, definitely we have to use the frequency division. That's it. God, it will take much of time. Yeah, so the bit stream will be completed. You can click on the Open Hardware Manager and click on OK. So open target, auto connect. So click on JKF profile. So 0 1 1 0 1 1. Why it is not showing it? Wow. Okay, it is revamping. Oh, sorry guys. I mean, there's a problem in my page about. Tomorrow earlierly I will show my output. Okay. Yeah, no need to worry about it. Tomorrow, I mean, tomorrow for earlier class, I will show my output. There is a technical glitch. I mean, my FPGA board is not working properly. Okay. I mean, tomorrow for the earlier, I will check it. What's the problem? Okay. And tomorrow we are discussing about the LCD peripheral. How can we integrate it? Actually, today we need to discuss about it. But before that LCD, we need to you people are need to know the frequency division. Okay, because of the LCD is the very bigger peripheral. You know, it's lines of. I mean, it's nearly 900 lines of code nearly. So we need to repeatedly using the frequency division. So that's why I'm explaining this concept for the tomorrow class. Okay, yeah. Yeah, thank you. I mean, if anyone have any doubt, so please ask me. I will share the notes. For the tomorrow, I mean, definitely I will show you the output. Definitely, it is not a code output. I mean, no need to worry about it. It's a problem in my hardware, in my FPGA board. I think
I did not
there is
receive
a problem.
any email, sir.
Yeah, sorry.
I did not receive so far that material, any email.
Okay,
Sir, please check your spam mails once, sir. If not received, please let us know. Please ping me through WhatsApp, sir. We'll check it.
Okay, sir. I checked the spam, but in that also not there. I will ping you on WhatsApp.
Sure, sure. You just ping me your mail ID, sir. We'll check it with the team.
Okay, thank you.
Yeah. Tesh, is that completed?
yeah, yeah, today.
Faculty, thank you for joining. I request everyone. Yeah, sure. We'll share the code and commands. So tomorrow, please join the session because we are going to launch our biggest event, Scholarship Exam 2026, in tomorrow's session. And that's it for today. We'll again meet tomorrow at 6:30 p.m. Thank you, my dear faculty. If you have any doubts, Tej, please carry on.
No, yeah. Anyone have any doubts in the frequency division? You can please
Sir, I
ask me.
have one doubt.
Yeah, please, Raghuveer.
Sir, not about this frequency division.
Yeah.
Sir, actually, I have developed one code which I already dumped into my Z board.
Yeah.
Okay, and again have to take the data from another device, which I need UART protocol.
Okay.
Should I go for another Z board or should I integrate the same code which I have dumped into the same Z board?
No, no. If you want to communication between the two boards, definitely you have to use the UART protocol is the best one for the communication of two boards. No, no. If
Yes,
you
sir.
want, I mean, if you want to share it internally, definitely I think is this same on same peripherals or different one? If you are
Different.
different peripherals, okay. For which is the which peripherals? I mean,
No, actually, I have developed a one model, digital model for railway interlocking and all.
okay,
Okay,
okay, yeah,
I have dumped into that Apple Pro SX3 kit.
okay,
Okay, I have to transfer the data which is stored in the data logger.
okay, 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 okay.
So and here my doubt is, should I use the same board for my hardware model, and again I have to go for another Z board or another board for UART protocol to transfer the data from data logger to which I have developed the hardware on Actel Pro S3 kit.
No, no, one board is enough for this one. I will check it. Give me some time. Your name is Rob. Yeah, I know it. Tomorrow I will be answering it. Definitely, I will check and I will check. I will tell the solution. Okay.
Okay, sir.
Give me
Okay.
some time. Yeah.
Okay,
Give
sir.
me
Thank
some.
you.
Yeah. Thank you.
Thank you. Thank you.
Yeah. Anyone have any doubts? You can please ask me.